now on session 6 of our Python course. So let's get right into it. So as part of our schedule today, we will be going through our second part of week 6, or second part of object programming. So week 6. And then after that, we'll move into advanced programming. Unless sometimes though, we may have to carry into, we may have to go, maybe part of object-oriented programming might carry into advanced programming, but we'll see how things go on. Okay, so how many people are think they're doing pretty well in their final project? Type in a 1 in the chat if everything's going okay for your final project. Okay. Great. So most people said that they wanted to create a game for their final project, and that's great. Just keep in mind, if you do finish early, your final project early before week 6 or week 9, sorry, then your final project is too simple for your level. You should always be working on your final project up until the end of the course. You can add as many things, like maybe if you finish early somewhat, there's always some way you can improve your program, right? So if you create like a game, let's say, maybe you could add some new features, right? Like maybe you could make some kind of special secret add-ons to your game. Or if you were making an application, then you could try to improve on your application in terms of like big O efficiency and that kind of thing. So there should always be some way for you to improve onto your final project, and you shouldn't finish early in a sense. You shouldn't finish your project before week 9. Your project should be, because if you finish it early, then think about it. It's too simple for your level. You're all very smart. You're all coming to this class regularly, so this final project should not be something that you finish too quickly, in a sense. You can always add on to it to make it better. Okay, great. So before we go into today's lesson, let's discuss the quiz. Okay, so here we have our quiz, and I have to say that this wasn't the best quiz that I've seen in this class. Nobody got a perfect score on this quiz. Usually in every other single week so far, there's always been at least one person that got a perfect score on every quiz. This was the first quiz that we've had that nobody got a perfect score. So we're going to be going over some of the questions from this quiz. So let's start with the first one. So this is just talking about your final project. These first few questions, I just gave points for those, just as participation for the quiz, because there are some people. We will be releasing the honor rolls, right? I think I forgot about that. We will be releasing the honor rolls, the updated honor rolls with the last quiz in our next weekly email. So be on the lookout for that. Keep in mind, you have to reach level 5 before week 9 to earn your certificate. So make sure that you're doing all the quizzes. And remember, if you take notes and then you email them to us at our email, then you will be given extra credit, which can boost your chances of getting a certificate earlier on in the class. Okay. So the first question, what is a Python object in your own words? So a Python object is just, you can just think of it as just an object in Python, right? So it's like some sort of data that's in Python, some way to represent data. And it's defined by a class, right? So a class basically sets up what an object in Python would look like. So there are a couple of ways you could answer this in your own words, like an object has different attributes to it. You could say an object is a data structure in Python that has different methods, different functions that can be called on it, and so on. There are a couple of ways that people answered this. Most people got this correct. There were some people, I actually found 2 people in this class. Let's see if I can. Okay, so here are the responses, right? And let's go to that question here. So describe what is a Python object in your own words. I think that there was someone that might have copied. Yeah, so look at this response here, where someone said an object is a collection of data like variables and methods like functions that act on those data. And then look at the response down here. Object in Python is simply a collection of data, in parentheses variables, and methods, in parentheses functions that act on those data. So both of these sentences are almost exactly the same word for word, right? These are almost exactly the same sentences. So on suspicion, I actually Googled both of these responses, and I found that this was copied from the internet, which is plagiarism. So whoever answered these responses for this question got 0 points for this question. If you copy an answer from Google, and I mentioned this before in a different class, but copying answers from the internet or from or work that isn't your own can be considered plagiarism. And if you plagiarize in your quizzes, then that question will receive 0 points. So be sure not to plagiarize. Even like this person just wrote 2 words, a class. Maybe that's not the best answer for this question, but at least it's not plagiarism. So they still get, at least some points, right? As opposed to, 0 points for plagiarizing. So just be sure not to plagiarize in the future. If you answered other questions that were not plagiarized, then those questions still got points. So yeah, just in the future, be sure not to plagiarize. Okay, and then this next question, how would you print the name attribute of a cat object whose variable name is X given the class below? So here we have our class, it's called cat. And when we instantiate a cat object, the cat is given an eye color, a weight, and a name, right? So, and in this class cat, we have a method where the cat can meow, and that just prints meow. So what we want to do is we want to print the name attribute of a cat object whose variable name is X, given this class. So we can do that by so what I was looking for was just print and then X dot name, right? No parentheses after. Because remember, an attribute for a class is just the variable that's defined in the class, right? So if you remember, here was our fun little program from last time. And I think we did, what was it? So here I have a circle object. And then if I did the variable name for the circle object, and then like radius, like that. Oops. So here's our circle object. It has a radius of 2. Then if I run this, it just prints out the radius. And remember, we call this an attribute. Okay, so let's move on. This was what I was looking for, in fact. So assuming that we had a cat object and the variable name is X, so there's a cat object and its variable name is X. And then here's the class definition for the cat object. How would we print the name of this cat object, which is X? And so this was what I was looking for. Remember, if you capitalize print, this will not compile. So be sure to type in print in lowercase, like that. How do you define a method for an object in Python? So this, you could answer this a couple of ways. There were some people that gave examples that said like def, and then like the method name. Some people said the init method. these all work. These are all different ways you can define methods for an object in Python, or a class in Python. What is the return statement in Python? The return statement in Python is just what you use to end a method. We'll be reviewing some of these things in today's class. If you think you've missed a few of these questions, don't worry. There were a lot of people that missed several questions. This wasn't the best quiz in terms of scores in this course so far. So we will be reviewing some of these questions and what the answers should have been later on today. So what is the purpose of the init method? So recall that the init method is what's run whenever a object of a certain class is created, right? So if I was instantiating an object, the init method is what is immediately run. And we'll be reviewing that today. Okay, so let's get on with the lesson. First, we have functions. So can anyone tell me what a function is based on what we went over from last class? And if you're not sure about your answer, that's fine. There's no wrong answers, or no wrong questions. Sorry, or no stupid questions. I think that's what the phrase is. But if just tell me what you think a function is in Python. Type in the chat. Yeah, so a function is in Python is what we use to perform some sort of calculation, essentially, right? So what we're going to look into functions today is functions have the DEF keyword. This is how you define a function, right, to perform a task. So we can define a function of a class, define functions of an object, and so on. You know, there's just endless possibilities what we could do with this. And parameters or arguments are what go in the functions, those parentheses here. So let's go to our program from before, which is over here. We have functions. This is the function here, def area, and then here we have the self keyword. We'll get into that later. And it returns, this basically just calculates the area of a circle. In this case, this circle object, right? So this is a function, okay? And then the return statement in a function. So in the entire language of Python, every single object, every single type of data will return something, right? So every function will return something as well. So here's the print. Print is actually a function in Python, right? So we have the print, and then we have two parentheses around, and then we type in what we want to print, right? So this is actually a function. And this function will actually return something. Can anyone guess what the print function returns? What does the print function return? Okay, so this was actually a trick question. The print function will actually return nothing. So if I said print, and then if I said print, and then if I typed in something to print, like, I don't know, A, B, C, D, it would print out this, but that's not what it returns. So if I said A is equal to print A, B, C, D, right? So first of all, can everyone see this Python shell that I have open? Okay, so remember, every function will return something. So this function is the print function, and this function will return something just as all functions do. And it will assign whatever this function returns into this variable named A, okay? So does that make sense to everyone? Okay. So now we have whatever this function returned is stored in this variable a, right? And then when I type in a, what do you think would happen if I typed in a? If I typed in a, I would get whatever this function returns. So if I typed in a like that, I get nothing, right? Because when I say print, this doesn't actually return anything. Printing and returning are not the same thing. When I say print, the print function, all it does is it just displays whatever's in between its parentheses into this IO, right? It just prints whatever you wanted to print. But it actually doesn't return anything. That's why you usually don't see something like a is equal to print, right? Because the print function, it doesn't return anything. That's not its purpose. The purpose of the print function is to print. The purpose is to display the whatever you wanted to display, right? So the print function actually returns. Can anyone tell me what the print function returns? Because as I said before, every function in Python will return something. The print function, it returned something, although we couldn't see it. Okay, so the print, does anyone remember what the none type was? We discussed this, I think, in like our first class, I think. Yeah, so the none type is just how we represent nothing, right? So if we wanted to create a function and we didn't want to like actually calculate anything, right? So let's say I wanted to create a function that was like, so def, and then maybe something like display, right? Like this. But I mean, if I'm displaying something, I'm not really calculating anything. Let's say when I display something, I print out radius. How about I say a, and then I'll make this an F string. Okay, so does everyone recognize what this line does? Okay, so some people don't recognize what this line does. Anyone in the class typing in the chat to everyone what this line would do? Are there any brave volunteers? Right, so the F string, it just prints out the variables that are defined previously. So before we have this variable called self.color, right? And so what the F string does is we type in the letter F at the beginning, and then we type everything else like a normal string. But for the parts where we want to insert the variable, we type in the variable name, and then surround that with these curly brackets, like this. So this will essentially just print out this variable. Whatever this variable is, it will incorporate that in the string. So if my, so here I have this as CIR is equal to circle 2.red. So if I said CIR dot display, right? Because our function name is display, then it will just print out this string. A red circle with radius 2. So recall the radius is 2 and the color was red. So I'm displaying what this circle is. Okay, great. So now we created this function. Can anyone guess? Well, this function, it didn't, notice we didn't use the return statement in this function, right? Because it just wasn't necessary for our use case. We weren't calculating anything. We didn't really need to use the return statement for anything, so we just didn't include it. But it's still, the program still ran, right? And the reason for this is because if you don't include the return statement in a function, then it will automatically be the same thing as if I did return and then none, right? So I'm not returning anything. So if you just made a function and put in what it was supposed to do, I'm not sure what you mean by that question. No, we defined this function here, and we named the function display. And so what this function display will do when it is called is it will do whatever lines are below in this indentation. So then when I run this is how I would run. So I created a circle object with radius 2 and the color is red. And then when I run this function here, it will just print out this f string, and that's all it will do. It will just print out this f string. The return statement does nothing, right? So it will return, because we don't have to return anything for this function. If I could do something like return and then say something like radius, right? I could return the radius if I wanted to, but it's not really necessary, right? Because all we want to do is display in this function. For something like when we're calculating the area and we wanted to actually return what the area is, then we would use it would make more sense to use the return statement, because we want to find what this area is. So if I did cir dot area, right? Can anyone guess what would happen? I'm not going to show you the output. What would happen if I ran this program? And the output is hidden, so this is not the output. Can anyone tell me what would happen? What would I see if I ran this and then scrolled down to look at the output? Okay, that's correct. So we won't print out anything, because notice we're not calling the print statement. We're not printing out anything. So let's, if you're still confused, we're going to walk through this line by line. So first we are importing math, right? But that's not really, because in this function, we're using math.py. So we have to import math somewhere. So we're just importing math. This line isn't really important to what we're proving here, but that's the first line we're going to run. Next, we're going to create a circle object, and we call that circle, the first thing we have to type in is the radius, and the radius in this case is 2. And then we have to type in a color, and the color, we said the color was red. And this is how you create the object, because remember, this is the init method. And we set that object to the variable, we assign it to the variable CIR. Okay, so now CIR is kind of storing this object, okay? And then if I do CIR dot area, Now we will go to this circle object. It will take this circle object and it will calculate and it will run this function. Okay, so first this function, what it does is it takes math.pi, which is just the number pi. If you don't know what the number pi is, that's okay. We're not really, what we're trying to prove is, we're not trying to prove pi or anything. So don't worry about that. And then we're taking the radius of this circle. So remember the radius was 2, and we will square that. So we're multiplying the radius and we're raising it to the power 2, and then just returning this is the formula for calculating the area of a circle, right? So we calculate the area of a circle in this line, and then we return it. And when we return something, remember that returning something is not the same as printing something. Returning something is like, now this this line cir.area is like the same thing as a number. So if I typed in something like 12 or 13, this is just a number, right? It's not printing anything. It's not calculating anything or anything like that. It's just a number, and we just use this number to represent some sort of data, right? And if we wanted to, we could assign this data to a variable like this. So a equals 13. The number, it's not really, it doesn't print anything or anything like that. So just like that, when I say cir.area, this is, think of this as like a number, right? So it's just represented by whatever the area of this circle is. So when I return cir.area, it's just, think of it as just a number. So a equals cir.area, and then if I printed a like this, then I'd get the area of the circle, right? Does anyone have any questions or want me to repeat that? Just say so right now. Okay, so nobody said they want me to repeat that or anything. And so I'm just, since nobody said anything, I'm going to assume everyone understood. And then last we have the star, and then args. So what this does is, if we type in stars and then args, what this will do is this will take in all the arguments that are in this line here. So this line is what you use to define a function, right? So you know what, let's create a new, for this purpose, let's create a new program. Let's say that we are trying to great. So let's say that we want to create a program that will, maybe we could, I don't know. Let's just say we want to make some sort of, let's just say we want to calculate the area of something, right? So to make a function, you don't actually need a class or anything like that. You can just say def, and then if you want, you know, to make this more simple, let's start from a clean slate. And let's say we want to calculate the area of a rectangle. So def, and then the length, comma width, like this. And let's name this function calculate area, okay? And remember, to make a function like this, you need a colon at the end, an indent, and then to calculate the area, all we need to do is just multiply length times width, right? So nothing too difficult here. And then we want to just return this. We want to return length times width. So what we could do is we could say area is equal to length times width. And then we want to return the area. So return area, like that. Okay? So does everyone understand what these three lines do? Does anyone not understand what these three lines do? Okay, so nobody said they don't understand, so we're gonna continue. So if I made something like length, let's say I have a variable called length, like that, and length is 10, equal to 10. And then I have a variable called width, and width is equal to like 20. Then I could, and let's say I wanted to print out the area of this length times width. So I could just do, I'll say area equals calculate area, because that's the name of this function. And then to calculate the area, I need to enter in the length and the width, like this. And now I'm going to print the area, like that. I'll just save it and say, okay, so this is just printing out the area. So 20 and 10. But let's say there's also more, right? So maybe there's a length, width, and then you could have a height, right? Like that. But now if I add height, then now I'm going to need three. Now there are three different variables that this function needs to work, essentially, because that's what I've inputted here. But here I didn't give a height, so that's why it's giving an error, saying missing one required positional argument height. We didn't enter in the height of this to calculate the area, right? So what we could do is we could say star star args, like that. And what this does is it takes in whatever number of arguments that you have, and it will just store this in to the variable args, like that. So now if I ran this, it's still, I don't get that error. And what this does is, so now I could give, I could give as many different arguments as I want, right? So 1, 32, I don't know, 100, and this would still work. That's what star star args does. Let me just check my notes. Okay. So, see, it takes 2 positional arguments, but 6 were different. Star args? No, star args. Oh yes, maybe it was. Okay. So maybe it was star args, not star star. Maybe it was just 1 star. Not star. Okay, like that. So if you say star args, you can give as many arguments as you want, and it will still work. It will still compile. But you might think, what's the use of this? Why don't I just have? Well, the use of this is now, instead of just limiting only 2 different arguments that can be taken in, you can now actually access star args. So if I said for I in the args. And then maybe we could calculate the sum. So sum is equal to 0. So I'm changing this function to, so calculate the area. To calculate the area, you really only need the length and the width. But let's say you're doing a different function like the sum. And so for I in the star args, sum plus equals I, right? And then return the sum like that. Okay, let's keep that. And then sum. Let's say S. Okay, so now, no matter how many arguments I pass in, we'll calculate the sum. Let's say T. Okay. Okay, let's do len. Let's just count the args then. That won't work. Okay, so what we're going to do is we're going to count all the arguments that you pass into this function, and then we're going to just print out the number of arguments that you pass in. So print out len of star args like this. Okay, this is not the best. Let's just move on. Ignore args for now. We'll go over it later. What is len? Len is just the function you use to calculate the length. So if I had the length of if I had a list, right? So list A, B, C, AB, ABC, D, right? D is not defined, right? Okay. All these are strings, right? Like this. Okay, so this is a list of strings. And then if I typed in len, and then that list of strings, I'll do like this. So len, and then the list of strings, right? Like this. Then it will just give me the number of different elements that are in this string. So here there are 4, right? A is 1, B is 1, C is 1, and D is 1. So there are 4 different elements, so this should give me 4, like that. Okay, so the next thing we're going to go over is scope. So what is scope? Scope just means where you can see the variables, essentially. So which variables you can access. So to look at how that works, let's say we have a function, right? Let's get rid of this. Let's say that this function, all it does is return the length plus the width. Okay, so it just gives us the sum of whatever 2 values we pass in, like this. Okay, let's say in this function we also let's say we calculate this function in a weird way. So maybe we do something like s is equal to, well, it's not a weird way, but it's just we added 1 extra line, right? So in this function, we take in a length and a width. We add the length and the width, and we assign that to the variable s, and then we return the variable s. And then here we do sum, and then the 2. Let's cut this out, and then do control V. Sum, and then let's say we want to add the numbers 1 and 3, right? Like that. And we want to print it out. So I'll say S, or I'll say T is equal to sum of 1 and 3, and we're printing out T like that. Okay. So This should be a simple program. Everyone should hopefully understand what this is. If you don't understand what this is, please say so right now. So we can, because this is, you should understand what this is by now. Okay, so everyone understands what it is, what this program does. So can anyone guess what would happen if I tried to take in this variable s and print out s? No, you don't have to put in it s, because this is just for functions. You don't have to have a init. Init is for classes. Okay. Yeah, this wouldn't run because it says s is not defined. You might think, well, s is actually defined right here, right? But no, this is in the def. This is in this function. S is in this function. So if I try to access s, the variable s, and it's defined in this function, we cannot. We won't be able to use this variable. But we're able to use this variable here, right? So if I said print and then s, if I tried to print s over here, just comment this out, then it will work, because here we are able to access the variable s. It's in the same scope. So here the variable s is in the scope of only this function. So to use the variable s, your lines have to be in this function. Okay. Sum.s, no, that's for classes, not for functions. Okay. So we'll get it will make sense as we finish the lesson. So some examples are for I in range when we're looping through something, right? So if I said for I in range 10, right? And then I said print, let's say I said sum equals I, right? Like that. The variable I is in the scope of this whole file. So if I tried to print out I here, even though it's not in the loop, it should still work. I'll comment this out like that. So yeah, I can print out the variable I. It's not in the scope limited to only this function. This printout statement can be outside of the loop, and we can still access the variable I. So that's an example of what's called file scope. If the variable can be accessed anywhere in this Python file, then it has file scope. But this variable here, it cannot be accessed anywhere in the file. To access the variable, you have to be in this function. So this is called function scope. It does not have file scope. Okay, so let's move on. So methods. So recall that a method is just a function that's in a class. So here we have a, let's go back to our classes. Let's get rid of this. So here we have our rectangular prism and our circle class. Over here. So since there's a function inside the class, so here we have our class, our rectangular prism class, and there's a function inside this class. Functions inside classes are called methods. So in case you were wondering, why do I sometimes call it a function? Why do I sometimes call it a method? That's because, I'll type it here. So functions inside classes are methods, right? So this function is inside a class, so it is a method. Okay, and there are three main types of methods. The first type is the static method. So static methods, we add what's called a decorator, and the decorator in this case would be a static method. We haven't discussed what a decorator is yet. So if I said static method like that, just for right now, think of a decorator as just a label that Python uses when it's running the program to identify what a static method is. So when you're using a static method is just basically a function that Python does not automatically pass arguments into. So if I said function, if I made a function, right? Let's say I called it to make this a static function, you just add this decorator at the top, or I think it's static method. Yeah, static method, like that. And then all it does, let's say that this method is returning the string hi or something, right? Print some, like that. Okay, so let's say that here I have my static method and I'm running that. Oh, whoops. Oh, this should be in here. Because remember, methods are functions that are in a class. So we need to put this in a class to make it a method, like that. And then I want to print out some, right? Well, you probably won't be using static methods very often in Python, mostly because you'll be using the other two types of methods more frequently. And a static method can be called by a class and an instance. So here I have rectangular prism. If I said rectangular prism dot f, like that, that's what it's called. No, sum dot sum. Then, oops, what is that? I'll give this, what was it? Okay. So even though we didn't create a rectangular prism object, remember, to create an object, you have to do a rectangular prism like that, and then maybe give it a variable name, and then add some parameters, right? So length, width, whatever, color. But notice we didn't do any of that, but we're still able to run this function here on a class, on the class name. So that's what a static method is. The next type of method is the class method. For this, we use this decorator, and it takes in a class as a first argument. So let's make this a class method. While I'm typing, feel free to ask any questions. Why would you use a static method? Well, you might find a use case as you go along into your Python journey, like maybe if you're a developer or and you're developing some kind of special sort of class. Yeah, you'd find more use cases of this as you become more advanced in Python. But for something like your final project, you might not use a static method, if that makes sense. Okay, so now we have the class method. So what a class method does is it will take in a class as the first parameter. And recall that our class is a rectangular prism. So when I do this, I could just return a new rectangular prism like this, so CLS, like that. And I'm just completely skipping the init method. Remember, for init method, you have to do a self, you have to do height, width, this, and all of that. But in this case, we're just going to do, we're still going to have to add different kinds of something for all of these variables, but we're not even going to have to call the init method. And you'll see how that looks like in a sec. So let's give this a height, so 1, 2, 3, or something. And let's make this blue, right? So maybe this class method is called blue rectangular prism. And so all this is doing is it's just returning a new rectangular prism that is blue. So let's do that. What was it called? Blue rectangular prism. like this. Oops. Oh yeah, right. Self, let's get rid of self. Yeah, so we created a new rectangular prism that is blue. Right. Let's yeah, so recall that this is how it looks like when you try to print an object. So we didn't use the init method, right? We didn't have to do something like a equals rectangular prism, and then 1, 2. So we could have just done this, right? But this is just another way to do it because this is a class method. So note that both of these lines do the exact same thing. It's just that one of them is arguably more easier to read, right? So I could say, instead of defining explicitly the height, the width, and the length and the color, you could just say, I've now created a method that will make a new object with all of this. So both of these, so lines 51 and 52 both do the same thing, essentially. But why would you use a static method? How would it know that 1 is a height and 2 is width, 3 is length, and 2 is color? Okay, so if you look here, our class method, we take in a class like this. So CLS is how we represented this class, rectangular prism. And then just think of this as we're taking in the rectangular prism and replacing it with this word class, CLS, right? So CLS is the rectangular prism, right? So normally when we're creating a new rectangular prism, we do rectangular prism and then we type in 1, 2, 3 blue. In this case, we just did, since this is a class method, we took in a variable to represent the class, and then we did the same thing, instead just using the variable name. Okay, so does that make sense? Yes. Okay, great. Let's continue because we're running out of time. Instance methods. So instance methods are the methods that I'm sure you're all familiar with, like methods that use the word self. They're methods that are in a class. So here I have the class circle, and this is an instance method that uses the word self inside. It doesn't use any decorators. All we do in an instance method is we can access the attributes of a class. So recall that an attribute is just a variable that's defined in this class. So it can be defined in a function like this, or it can be defined like something like this. So x equals 10 or something. And then you could access this by saying, this. So A is our circle, or no, CIR is our circle, right? So if I did CIR dot x, it would just return this value, right? Because we defined a variable called x in this circle. So if I do CIR dot x, it will give me the value of x. Okay, so and they're defined in a class, and they're called on an instance. We call that an instance is just wherever you create a new object. So did everyone understand what we went through so far? These 3 methods, or 3 types of methods. Okay. And there are more special, important methods. I'm not sure if we have time to go through all of them. But recall that init is an example of a special method, right? We use 2 underscores and 2 underscores again. And whenever the init method is run, it's run when we create a new object. So if we do circle 2, comma red, it will run the init method. But there are other methods too that are special, and we'll do something like that. There's repr, which will just represent the class as something. So let's create, let's just go through the first one, which is repr. So let's say, let's change this to the repr method. So all it does is it takes in, takes the object and it represents it as a string. So I could return this string, right? So now if I did print, if I tried to print out the circle, right, like that, instead of getting before, when I tried to print out the circle, I would get this. It would give me the memory location on my computer, on my hard drive, of this object. But now with this underscore repr method, when I try to print out the circle, I get a nice clean, it's I'm sure you can tell that this is more, you'd probably want this as when you're printing out an object instead of something like this. It's just better to look at, right? And like that, there are all kinds of other methods. So repr and str, those are both pretty similar in the how did I get that? Do you mean how did I get these methods? Is that what you mean? In the chat question, there's a question, no. Oh, how did I get this clean? I used the repr method. So I created a new method called repr. And then in this method, I returned what the string I wanted to be returned when this when I try to print this out. So when I try to print out a circle, I could make this really anything. So if I wanted, I could say a circle like that. And now when I run it and I try to print out this circle here, I'll just get a circle, right? So if I did, let's say I try to print out a list. So circle, and then 2, comma, and then the color, which is blue, for I in range. This is like the last slide from yesterday's lesson, in case you remember. So now I have an array of, or a list of circles, right? As opposed to having something. So before, without this repr method, it would look like this. I'd get the memory addresses on my hard drive. Okay, so does that make sense for that specific, for this specific special method? Okay, great. So there are all kinds of other methods out there that are special and are worth looking into for your final project. We're out of time right now, so but before you go, there is a competition that I wanted to let you all know called Google Kickstart. And based on whatever you know about Python so far, what you learned, what I've seen some people do in the quizzes, you should all be pretty much set for competing in your first round. So look up Google Kickstart's coding competitions. These are international, but don't think of it like something that's maybe you're too young to do it or anything like that. For round C's, first place was done by I think it was round A. Yeah, round A. The first place winner was a high schooler, actually. So he was in high school and he got first place in the world for this competition. So round D is going to start in about 12 or 13 hours. So if it works for your time zone, it's definitely something to look into. And I encourage all of you to participate in it to help hone your skills. Some of the problems will be difficult since this might be your first time competing. So don't take it as something that's the end. And right before you go, I'd like to have all of you to solve this problem in like the next minute. So just type your answers for this problem in the chat, and that would be the end of our class. So type in the answers for this question in the next 1 minute. Yeah. Okay, so we had one person answer, and their answer looks pretty much, their answer looks fine. So we're gonna walk through it right before we end the class. So given two int values, return their sum. Unless the two values are the same, then return double their sum. So if the two values are the same, then we want to return double their sum, right? So let's check for that first. So if A is equal to B, like this, then we want to return twice their sum. So we could do return A plus B, and then times 2, like that. And then we could say else return, and then we just want to return their sum if they're not the same. So return A plus B, like that. Okay, so this is correct. If you want, you can see the solution, which is pretty much the same. They did it in a slightly different way, but hopefully it's the same intuitively. So that wraps up the end of our class. Thank you all so much for coming, and we'll Be sure to look out for the quiz. Participate in Google Kickstart if you can, and I'll see you next time. Thank you.